Oh, you guys are ready to start whenever you'd like.
Thank you. Okay, well, welcome everyone to the Enphase Energy STEM engagement. We've got a couple of our engineers here. We're going to talk a little bit about our organisation, what we do, what some of the guys do here, and a little bit more about what we have in terms of roles and career development here at Enphase. I'm going to pass you over to our site director, Gary, who's going to give us a bit of an introduction.
Thank you, Jen. Okay, so Enphase opened in New Zealand in 2011 and moved to our current campus in 2015 with 35 staff. We now have more than 80 staff here on site, and we're still growing. We're still putting people on. There's a continuous stream of people we're looking for, and we're just growing more and more. So here's an interesting thing. In a single hour, the sun generates enough energy to power the lives of every human on Earth for an entire year. Imagine if all that power was in your hands. So Enphase, we are working on a sustainable future with cutting-edge power electronics technology to provide renewable energy for future generations. Energy independence is becoming increasingly important. And at Enphase, we're doing our part to enable this future with energy storage solutions and the ability to produce power both on-grid and off-grid. So we're part of a worldwide company here in Christchurch, where we have offices in Fremont and Petaluma in California, Austin in Texas, Bangalore in India, as well as manufacturing and regional sales and support offices around the world. Enphase Christchurch is the primary centre for microinverter engineering, incorporating power electronics, mechanical, embedded firmware, systems engineering, quality, and compliance. So we're going to talk about these amongst us here in the room over the next 15-20 minutes. And to start that off, I'd like to hand you over to Graham, who'll talk about the power electronics hardware engineering.
Thanks, Gary. My name's Graham Marshall. I've been at Enphase for 10 years. I started out as a design engineer and I've moved my way up now to being a hardware manager. I manage a team of about six engineers, and we have approximately about 25 people working in the hardware group in New Zealand. About probably 18 of them are design engineers, and then there's probably 7 support staff. We also have a advanced research group here who are not designing the next generation product, they're designing the next generation of the product. So, you know, we span the thing from developing the product, supporting it in the field and manufacturing, to doing the next generation product development. So if we start, what do we actually do here? Now, Enphase New Zealand was actually started out as a sort of power electronics design centre. And if you look at that second picture on the from the left, that's a microinverter. And if you look on the far left, you'll see that that's actually what it looks like inside the box. And this is what the hardware engineers work on. So you can see in there, there's power electronic switching devices, there's SMT parts, there's control chips, there's magnetics, capacitors, conductors, connectors, and hardware engineers touch all these bits and are involved in design. They're involved in design of the PCB and pretty much what goes on inside there. So once we've done our bit, then the mechanical engineers take over, and they design the plastic enclosure, and that's what you can see in that second picture to the left, and that's what the customer receives. So where are these used? Well, they're used on, so the whole point of the microinverter is that we put a microinverter on the back of every solar panel. Where a lot of other people out in the industry, they'll connect the solar panels together and then just have one inverter. Big inverter, where we put a microinverter on each solar panel. And that offers numerous advantages regarding shading, gives you flexibility to upgrade, and there's other safety reasons why you want to do it. We also design the power electronics box that goes into the battery, and that's what you can see on the far right there. And, you know, a lot of you have probably heard about the Tesla Powerwall battery. Well, we make a competitive product to that. And so we've got multiple of these microinverters into that product. Okay, Jim, if you want to go to the next slide. So what do hardware engineers at Enphase do? Well, obviously power electronics. And then we also have to have knowledge about system and control design. We have a lot of high frequency magnetics in our design to do the power transfer and also do the EMC design. And EMC is a big part of our job as a hardware engineer because we have to meet the compliances so we don't interfere with your cell phone or put out noise on the grid. And we don't get interfered by anyone else creating noise in the grid. So how do we test these products? Well, we use test automation because these products are so complicated. It's too hard to just manually test them on the bench. So we use a lot of automated equipment, and to control them, we use Python code. The hardware engineer also has to be involved in a little bit of the firmware design and debugging. We actually make our own chips at ASIC. We have a design team in Petaluma, in Silicon Valley, and we get involved with them in the design and verification of the ICs. Enphase offers a 10 to 25-year warranty on our product, which is quite extraordinary in the industry. So that means that our hardware engineers also have to be experts in reliability engineering. So we spend a lot of time trying to get the failure rate as low as possible to meet that warranty. And also we sell these products around the world, so we have to achieve international certification. So we do a lot of work with our compliance people, designing the product to meet these international standards. I'd now like to hand over to Rick, who is one of my young engineers in my team, who can tell you a little bit about his experience of working at Enphase. Okay, Rick, take it away.
Yeah, hi, I'm Rick. I got a slide all to myself. There we go. I graduated from UC about 2 years ago. I studied electrical and power engineering. And I started work at Enphase as my first job out of uni. Obviously, the key papers at uni were the embedded systems and the power electronics courses. They're definitely the most helpful courses, but I certainly found that all the papers had a lot of relevance for life as a working engineer. Since I've started at Enphase, I've worked on a variety of projects. So working on both the solar inverters and the battery inverters, and working on, for example, new products, solving problems that come up with them, and as well as our fleet of existing products. And some of the problems I deal with, or some of the sort of work I have to do, the issues I sort of have to solve. Sometimes they're really low level hardware problems, so I have to use the test equipment we have here. There's all very high end oscilloscopes and power supplies, so on and so forth, to capture these tiny hardware glitches that might only be tens or hundreds of nanoseconds long, and try to figure out what's going wrong with the hardware. And equally, we can get high level software problems, in which case I have to write embedded C to solve these software problems. And most recently, I was involved in upgrading the MPPT algorithm for the PV inverters, the solar inverters, to try and make the off-grid performance a little bit better. So that was really interesting. It was really cool being able to work on these, really relevant technologies in the sustainable engineering space. And it's all very much cutting edge stuff as well. So that was really cool. Every time we solve a new problem or find a new problem for that matter, we have to be able to test it. So I've created several automated testing programs in Python to be able to automatically test that the solutions we develop do actually work and that they don't have any hiccups along the way. Along the way, I've been mentored by experts. Every time we write code that has to go on the inverters, it has to go through review. And every time I do that, it's a bit of a painful process, but it does get easier every time. And I definitely can tell I'm getting better at it and picking up new skills from them. So that's really awesome. And finally, I've been able to work alongside teams in New Zealand, India, and the US. So most recently working with one of the teams in the US with stuff with the ASIC that trying to figure out exactly what's going on there. But no, it's all really cutting edge stuff and I've really enjoyed it.
Thank you. So I'll talk about the firmware and the embedded software that we work with here at Enphase. Okay, so the hardware inverters, we've got cutting edge embedded firmware. So the role of the embedded firmware is to control the behavior of the hardware in conjunction with the ASIC, for instance. in real time, so the inverter is operating at its most efficient. Given the variation in things like solar panel outputs, for instance, we have to vary the way the hardware behaves, depending on how much the solar panels are actually outputting, etc. There's also a lot of work involved in various regulatory requirements, for instance, that we have to meet. So there are times when we may have full sun, but due to the way the systems are set up, we actually have to cut back power production, so we don't push too much power onto the grid, that type of thing. As an embedded engineer, knowledge of systems and control design is essential in meeting some of these goals. Christchurch, we also have an embedded firmware team working on our gateway products. And this particular team manages the communications between the microinverters, our storage, our switchgear, mobile applications, and web services. This involves different types of communications protocols and the routing of this information between the various interfaces. So whether you're interested in working close to the hardware, such as the bare metal, working with an RTOS, or even writing drivers and applications for embedded Linux, we cover all of these at our Christchurch campus. C and C++, they're the programming languages that we primarily use, with other scripting language being used, particularly on our embedded Linux products. So people will do bash scripting, we do a bit of Lua scripting as well. So it's not just restricted to C and C++. Also, as part of being an embedded firmware developer, development of scripts to support debugging and testing is done using Python, of which we have our own Python test framework that enables interaction with the inverters and the test equipment. So this enables us to have a fast and reliable way to debug and test. An important part of being an engineer is to have developed problem-solving skills. So your university education has started you on that journey. And at Enphase, we can take you to the next level. Problem solving is what we do every day. And part of the fun is finding new and unique ways to solve complex problems. And there are no shortage of complex problems. We're right at the start of all this. Finally, we expect our engineers to have critical thinking skills. Never assume and always question. All of our embedded firmware is peer reviewed, and we assign mentors to assist new graduates in growing these skills. So I'd like you to hand over to Cameron, who's one of our graduates, and to tell you a little bit more about what he does.
I'm Cameron, and I'll talk a little bit about my experience here since I've started. So I studied mechatronics at Canterbury University, finished about 3 years ago. And since then, I've been lucky enough to land a role here as a microinverter embedded firmware engineer. So I've been able to do quite a wide variety of areas since I've started here, but my main role is microinverter embedded firmware. So something we do every day is write firmware. So we develop C code primarily for the ASIC that we use in our microinverters. So the ASIC uses a processor with a bunch of extra blocks of the chip for power control and that kind of thing. So while working on it, you end up working in a pretty wide variety, everything from power control to flash management to PLC communications. And some of the more interesting aspects since I've started is we've been working on getting off-grid capabilities in our inverters. So this is fairly new ground and finding a lot of challenges, and it's been quite an interesting process. So while I was studying at UC, some of the courses that I found quite useful since I started here are power electronics for hopefully obvious reasons. Also embedded systems. But one of the least obvious ones that I found personally was quite useful was the computer architecture courses. So one of the challenges we have writing firmware for the microinverter is it's quite a constrained system because we produce microinverters at quite a large scale. Every cent counts. So you've got to, it's not worth it to add a quite complex and costly chip in there. So we add chips that basically give us just what we need and nothing more. So some of the other things I've touched upon since I've started here, besides my primary role, is I've done some work on DBT, or design verification testing. So that uses the Python test framework that Gary's touched on already. Something else I've done is I've been in the design process for one of the Python packages, and I'm actually the current maintainer for it. So this is the package that we use to communicate with inverters for testing and also for debugging, in particular for remote systems. So you might find at Enphase there's, because we work globally, there'll be a test system showing a problem somewhere in India, and we obviously can't get physical access, so we need to be able to work remotely on those kind of systems. I've also been involved in some other embedded C projects. So I've worked with some coordinator code and a device that acts as a PLC bridge, power line comms from the PC to the device. And finally, I've found that the people here are generally quite, they are really good to work with. I found in particular my software development skills have really improved since I started, where new process and just generally chatting to people in my team has been really helpful. That's everything. Thanks.
Hi there, my name is Tristan Leslie, and I lead our team of mechanical engineers at Enphase New Zealand, and provide support from there to Bangalore and to Austin. There's about 11 on our team currently in New Zealand, but there's probably a total of 18 or 20 mechanical engineers just in the microinverter business unit. What does a mechanical engineer do at Enphase? Broadly speaking, you'll spend about a third of your time in design, a third of your time in testing, and a third of your time documenting the first two. So in the MBU, we're responsible for the design of obviously the microinverter enclosure themselves, but also all of the cables and connectors that go and link them together. So all of the most of the connectors are custom designed by us. So there's a lot of detail that goes into those. We're also responsible for the development of accessories that go into the systems, that such as relays, relay boxes, and communication boxes, and basically all of the enclosures that we design is one of the major reasons why we can achieve 25-year life on the roof. So there's some very harsh testing that we go through. We really put these inverters through their paces. We put them through highly accelerated life testing, cycling both temperature and soaking it in high humidity. We freeze them and drop weights on them. We run current through them continuously and cyclically. The whole process of testing an inverter can take upwards of 3 months to complete. Very intensive, and the recording of that information is critical to our success. A lot of analysis and measurement goes on as well. We need to make sure that these parts are produced accurately by our suppliers. We, Enphase, do not manufacture directly any of these parts, so a lot of supplier interaction. And almost all of our major components are made from injection molded plastics. So an understanding of how that process works is very important. Failure analysis, big one, because of course, if you're testing, you're looking for failures. We don't just test it to see if it can survive. We test it until it breaks and then find out why it broke. And that can take a lot of time and effort to figure out. So there's some very obscure failure modes that we see. And then obviously writing requirements and test reports, real key part of the role of a mechanical engineer. We need to justify all of the decisions we make, and we need to record those and be able to reference them later, and we can't pass through our development cycle without having all of that thoroughly documented. Next slide. So what are we looking for when we are hiring a mechanical engineer? Fairly obvious, highly important skill is your CAD modeling. We use SolidWorks, but pretty much any CAD package will give you the skills that you need in order to model the parts. An understanding of materials processing and performance, real critical. Anyone can design the right shape, but we need to make sure that it's made of the right material and that it is able to be manufactured and will last for 25 years. Statistical analysis, a lot of data goes through us. We need to make sure that we're making good decisions based on data rather than just our gut feel. Good written communication, really, really important. Everything goes into our records and you need to be able to communicate decisions and results. Probably the biggest non-technical skill that's important to us is the ability to iterate on designs with quality solutions and good instincts. Enphase moves very rapidly through development, so we need to be able to hone in on those design changes that we're making very, very quickly and do so with confidence. More so than the papers that you've taken, what's really going to be important is your practical experience, what you've done. So we'll be looking at the projects and placements that you've chosen to pursue in your time at uni, and looking for things that talk about designing parts, particularly plastics and injection molding, anything that you're designing for all weather conditions, specifically looking for experience with enclosures, cables, connectors, and testing of products is a big one, because our design engineers, as mentioned before, will spend about a third of their time testing. So that's an overview of our team, and to give you a bit more insight, I'll get James to talk to you about his experience joining Enphase.
Thanks, Tristan. So I'm a little bit unique. I work here at Enphase as a mechanical engineer, and I'm unique in that I studied in Australia, actually, not at UC. So I studied mechatronics engineering at Monash University, and I graduated in 2019. Moved to New Zealand, worked for a little bit, and then changed jobs here at Enphase. At uni, I found that I really echo what Tristan was saying. CAD modeling skills are critical. I was really fortunate that Enphase were using a software called SolidWorks. So at university, I actually did a SolidWorks certification exam as part of my university studies. That was really critical because I was able to evidence those CAD modeling skills. In particular, go alongside that, I'd say quite a big interest in CAD modeling is important. As a mechanical engineer, if you can show even just home projects where you have intentionally wanted to improve your CAD modeling skills, that goes a long way at something like Enphase. At university, I studied FEA as well, finite element analysis. That was really critical. Enphase does quite a lot of simulation work. So obviously, trying to be able to refine down the designs for our products. The simulation is a good way to iterate that. Systems engineering was critical. Gives a good oversight of how to work in a multidisciplinary team. And the inverters are very much a multiple system product. And as a mechanical engineer, you will likely touch on all those systems. And really, we literally speaking encapsulate those systems. So being able to understand all the different requirements, the hardware might be thermal as a requirement, but then there might be EMC reasons that we need to do things as mechanical engineers too. So that's critical. Manufacturing, highly underrated at university, but very, very important, practically speaking. As a mechanical engineer, we do a lot of work with our manufacturing facilities. As Tristan mentioned, we actually don't make them as Enphase, which means we're working with third parties to try and manufacture our products. That can lead to quite a lot of different meetings, quite a lot of discussions, which is where written communication is really and being able to convey those requirements is important. Moreover, you really need to be able to understand the different types of manufacturing and where they are useful and when they should be used. Being able to come into a role at university and understand at least the fundamentals of things like injection molding or machining or steam sheet metal, even processes like extrusion, really, really critical. At university, certainly the cross-functional projects were my biggest takeaway. Having studied mechatronics, I was fortunate to touch on quite a few different areas, including the hardware design and software. But what I found best at university were the projects where I wasn't working with other mechatronics engineers. We actually working with software or working with hardware directly. And that really allows you to essentially emulate what the real world will be like, particularly in a job like Enphase. You will work with all the teams. They all touch each other. In terms of work I've actually done at Enphase, I was fortunate when I came in, I actually didn't work on microinverters, although it is a critical part of what we do here. I started working on a new product called the Enphase portable energy system. So this is a portable battery, and one of the things that is really new about it is that it is consumer facing. So everything was critical, particularly things like every fillet, every texture on every surface really mattered, different painting materials. So it's a good example where Enphase doesn't just want to continuously repeat the wheel. We're always looking to develop new technology. And some of that might actually be developing our own way of doing things in a new area to us. And the consumer product side of things is very much a new area for Enphase. So I found that quite exciting. As part of that, I also was able to put my mechatronics skills to work and develop automated test equipment. It's one of the themes across all of Enphase is there's always testing. And when there's a high volume of testing, there's usually automation. So that was cyclic work. You can see a picture on the left there of a jig that was testing covers on this portable energy system. So that was really quite useful, getting to do a motor, getting to do some software and programming. So I would encourage people who study mechanical engineering to still try and branch out into some aspect of software. Even as a mechanical engineer, you always touch it. Just today, I saw a fellow mechanical engineer who was working in Python to try and do data analysis and extract information off the inverters. So really one of those extra skills that go a long way as a mechanical engineer. Another aspect we do is we iterate very quickly through designs. Additive manufacturing is critical to that. So we have two different 3D printers in-house, one being an FTM, the other one SLA. So I helped commission our new SLA printer, the Formlabs. And that's quite a cool bit of kit. So that really helps us to accelerate our timeline. But just last year, when we developed the portable battery, we would typically have to wait about a week to get parts out of Auckland. Now we can do that within 24 hours. And another thing that I think is quite cool in the mechanical engineering space is we deal a lot with test equipment, but also measurement equipment. So we have like an in-house metrology microscope. So one of the projects I'm leading at the moment is the procurement of a new high-value piece of metrology equipment. I think that really speaks to the fact that even as a mechanical engineer, if you have skills in other areas, they'll be called on. So I took quite an interest in process improvement and said, hey, let's try and do things better. And I've been able to lead the procurement of new equipment. So there'll always be opportunities for where you're interested. Okay.
My name's Alex Kendon. So I'm one of the systems managers here at Enphase. I've worked at a few outfits around Christchurch in New Zealand and ended up here running the systems part of the our systems team. So if you were listening to all the skills and the kind of work that we do in the other disciplines and thought that actually all sounds pretty interesting, in systems we touch all of it. We take the work that everyone else has done, we put it together and we try to break it. So when Enphase first started up, there were really only two system components that were the microinverters, and on a system like you see here on the slide, every one of the solar panels there would have a microinverter on it. And then there was a gateway that forms the bridge between those microinverters and the cloud reporting systems. Now Enphase has moved on since then. We've grown, we've moved into different markets, and now we really provide a full energy management solution for customers. What the systems team does is works with the customers and the market requirements and really tries to understand them and what do they need from that energy management system, what kind of things are they doing, where do they get benefit from it. And we take that and determine how we give them what they want using the system components we have, and maybe we come up with system components we don't have that need to be developed. So really what we're doing is looking at the real world applications and what the customer needs from the rest of the business to develop those. So next slide, please. And sometimes that can be quite interesting. People do things we don't expect with the systems, like they might put them on a playground and we have to think about, well, how do we get the communications between the microinverters that are sitting up on a panel at the top of a pole? Where do we put a system controller that can report that back? And what else might that customer be doing? Maybe they've got like USB charging ports for people to use. So there's all kind of interesting real world applications that we get to interact with and learn from in the systems team. And then we take that and convert it into actual products or requirements for actual products that the other teams can go away and work on. So there's a lot of scope for creativity there. We don't just design the systems, we actually have to test them as well. Like all the other teams, we do a ton of testing, but we are testing full systems. How do you test a large system? You have a huge set of lab gear. So we deal with, say, grid simulators that are maybe 50 to 100 kilowatts. And we then have to come up with ways to automate the tests and collect the data. So a lot of that testing requires new equipment that doesn't exist. So even though we're not designing the system components directly, we are actually doing design work. We are writing the test scripts. We are looking at ways to capture the data. We are coming up with ways to analyze that data. And every now and again, we are coming up with new hardware to allow us to do tests to replicate some oddball situation that's happening out in the field. So yes, in terms of the skills that we're looking for, if we go to the next slide, we are looking for the same sorts of skills that the other teams are looking for. We are made up of software engineers, hardware engineers. We don't have any mechanical engineers right now, but we're absolutely looking to include hardware and maybe even like IT in our team. So we really are a truly cross-functional team. As far as technical skills, what we're looking for predominantly is the ability to automate our tests, the ability to analyze the data that we get out of the tests, excellent written communication skills, because we are dealing with different teams all over the world. And sometimes we are forming the bridge between those teams. So good communication skills and an enjoyment of communicating across different teams is really important. But also there are some soft skills that are important to us. So we need to be pragmatic. As the team that puts everything together, we need to understand that there are different requirements and different limitations that each piece of equipment has. And we have to balance those against what the market needs, what the marketing team is asking for. So it is a balancing act, and the advantage, or the thing that I really enjoy, is at the end of that, if we do our jobs, we come out with a really good project or a really good product that hopefully satisfies everyone, at least to some degree. And also, we need people who, when they look at something, they don't just want to understand one aspect of it. If you're a person who really wants to understand every aspect, so if you pick up a phone and you go, this is cool, but how does a cell tower work? And then how do we get the data through, like, to the internet, to the other side of the planet? Like, what's all the stuff that's happening in between? If that's you, then systems is a really good space to be in. That's better for me.
My turn.
Thumbs up.
Oh, Ben Schrager. I look after all things recruitment and HR related here. And obviously you've just heard from all my engineers that I look after here in the office. So I'm going to give you the speech that I give most people that come through recruitment. I think it's really important for you guys to be our advocate out there at the university for us as well. We rely heavily on our what we call new college grads or university students. We are absolutely into promoting the growth of our technical leaders in New Zealand. I guess one of the biggest things for us is for you to understand that we are a multinational organization. So we are global. Although we are on different continents, we are one company. So people get opportunities to grow their careers, not just within the organization. For example, you know, Rick and Cameron and James telling you about, you know, where they are, what they've done. They can go anywhere with us here in Enphase as well. So we do have a lot of positions open at the moment. We're constantly looking for new graduates to come through. We want to fill you up with knowledge, get you to understand what we're doing, and put you to good use. Come in and have a look around. If you want to come and see what we do, we don't generally have product here in New Zealand. Our products are mainly sold in other areas of the world. So our name is still quite small in terms of that employer approach. Some of the things that we do every single year. So we do have the Enphase Summer Intern Program that comes up. And this is sponsored by the Callahan Innovation. So we tend to have as many students as we can every year. We do give a project out to individuals. So we don't just make you come in and do the butt work. You know, you're not coming in to sweep the floors and make us coffee. We want you to come and learn, to gain some experience. And it's an absolute opportunity for you to look at potentially growing your career with us later on down the line. So definitely a good chance for you to come through and take a look at what we're doing and get behind the scenes on some of the new projects that we're looking to work on, doing the research for us and getting well embedded into that. In terms of a long-term career with us, so we bring people on and we want to grow you in terms of your knowledge and your career with us. We offer things like stock units. So you come in, you accept an agreement with us, and we give you a handful of stock units. This gives you an opportunity to learn how to play around on the stock market firstly, but also as a big thank you to say, we're going to work you really hard. We're going to put you through a lot. You're going to test a lot of stuff. We're going to teach you a lot of things, but it's all going to be for the greater good of your career growth. So thank you every quarter with our quarterly bonuses. Now, I know a lot of companies talk about bonuses and profit shares. The nice thing about what we have with our quarterly bonuses is it's linked to your goals. So your goals are your aspirations for moving forward with Enphase. And these are set by our CEO, Badri, who sits at the top of the helm. He promises a whole bunch of great stuff to the markets and turns around to the engineers in the world and says, hey, this is what we've got to do. And this is now how we build on our goals for the quarter. So we write up a bunch of goals. We're all heading in the right direction, the same direction as well. And if you can keep those goals, at the end of the quarter, we all get ourselves a bonus, which is great. So we're working together. It ensures that we work together as a team, not just engineers working together, but myself as HR working with my engineers, marketing and sales working with the engineers. There's a whole lot that goes together to make the company great and to move forward. We also offer medical insurance here at Enphase. So that's really something that's quite helpful, mainly for us old people who generally need it. But it's great to have, not having to rely on the public system all the time. You can absolutely utilize this for you and for your family. So if you've got a wife and kids as well, they get jobbed in too. And we pay for a lot of you in terms of that medical insurance. A long service leave is also something that's really important to us as well. We work you hard, so we expect that you need to rest hard as well. So giving you an extra few days every now and again as you grow your career with us is something that we loop you into as well. So a big question that people tend to think about before applying for jobs here or they hear about roles becoming available is works well here. And I'd like to talk to this through our core values. And there's an image of our core values in the bottom right-hand corner. The people that do really, really well with us are those that are self-starters and team players. Getting involved in everything is really, really important. Waiting for stuff to fall into your lap isn't really going to happen here. It's about getting involved. It's taking your career into your own hands and moving things forward. We really value people that are eager at learning on the job. Going out and finding things that are going to strengthen your knowledge and allow you to move forward is really, really important. Problem solvers. Our problem solvers are our innovators here. We're working in a totally unexpected new space. We're making up stuff all the time. So this is an area where you can really learn to move through, innovate, and problem solve. We are customer focused. Our main value here is to give to our customers what we think they need. We're looking to advance a sustainable future for everyone on the planet. So everyone on the planet is our customer. We also have our internal customers. So these are your colleagues, the people across the desk from you. So we focus on all those different areas. Integrity is quite important to us as well. This is a market that is largely untouched. We're growing on it. Integrity is quite a big call for us. Quality focus, an area for us that we have to really, really focus on. We don't want stuff blowing up on people's houses. Hence the reason why the guys do so much testing. They break things all the time. Hence the reason why we call it a fail fast organization. We're here to break stuff. You get to innovate it and then you get to break it over and over again until you can figure out what's wrong with it or how to make it unbreakable. Being resilient is really, really important in Enphase as well. You'll often get things that will fall over. You'll go down paths with things that are absolutely fascinating, but then you'll recognize that perhaps we aren't yet technically advanced as a species yet to get to what it is that you're looking at. So you've got to shelve things and wait a little bit. Priorities can change as well. So being able to understand that you've got to move your position and look into different things. This is also a positive. It means you get to move around a lot to try out different things. Time management is also something that's really, really important to us. Because we are a global company, we've got to understand that we've got time zones that we've got to work with. However, we are one company, so we've got to be quite mindful of who it is that we're working with, when we're working with them. Setting a meeting at 2 a.m. for somebody just because it's 4 p.m. in the afternoon for you doesn't quite cut it. So we do a lot of work around figuring out what that looks like for everyone. So in terms of working at Enphase, if any of this sounds of interest to you, part of the change, if you want to advance the future of sustainable energy, if you want to come in and work on really cool stuff, Enphase could be the place for you. And that's it from us. Any questions? Taking questions in the chat. Where is it? You to ask any questions?
Hi, thank you so much for your presentations. I had a question. Do you take people who have a PhD degree for a graduate position, or are there any kind of R&D projects going on in your company? Thank you.
Okay, so yes, we do take people who have PhDs. As Graham mentioned earlier, we also have part of our organisation known as the CTO. They also advanced research, and as Graham said, next product and the next product. So we do certainly have openings from time to time for areas in that particular part of the company. And bear in mind that Christchurch itself, our Christchurch, is made up of a number of different business units. So we have some CTO, we have some quality, all sorts of different representatives of the company are here in Christchurch. So yeah, there's certainly things come up from time to time.
Great, thank you. And one more question. Which software do you use for FEA analysis?
That's a good question. I'll take that. We are currently using SolidWorks. We use the built-in FEA, but we are exploring some other options, particularly some of the newer ones, which work on a model that doesn't use finite elements. They work on like a continuous model. I haven't been super involved with that particular area. But no, we don't have anything really advanced. We're not using, say, answers yet. But I think we're probably going to push down that direction.
Okay, great. Thank you so much.
Thank you. Ryan Smith has asked a question. Do you have to intern to get a grad role? The answer to that is no. We quite often just have grad roles available. So no, you don't have to intern first.
Any other questions?
If you are not comfortable unmuting your mic, feel free to drop them in the chat for the company to answer. Cool. So maybe if there's no more questions, we'll finish up there. It is coming up 2 minutes to 10 minutes too. Thank you very much for this presentation. It was really, really good. I'll stop the recording.